Welcome back. So in this video, what we're going to talk about is we've been building out our app, and if this is your first video, there's a few other things that we've built before this. We've been building sort of this idea of a volunteer application, and right now, when we start it up, what we get is it goes straight into a list of all of our volunteers that are reading from a database, and we can create new volunteers and edit them and whatnot. But this is sort of like an administrator's view. Typically, you wouldn't show all of your volunteers to all users. You'd probably allow people to have their own access to their account, so to speak, but you wouldn't let them see everyone else and everyone else's phone numbers and birthdays. It'd potentially be a conflict of interest. Maybe not a conflict of interest, but a security issue for sure. Anyways, so what typically happens is you would log someone into the system, and then based on their profile, they'd be allowed to see certain things. So an administrator might be able to see all of this information, but as an end user, perhaps I could only see my own personal information. So we're going to build out in the next few videos a way of handling this. And the first aspect of this is this concept of logging in. So in order to log in, we need to get people to create a password and store a password for each user. Now, in our database, that's very easy to store information. So if we go to our database, we could easily add, another row here called password. And let's do that. Alter. Okay, and let's do something like update password. Sorry. Update volunteers. Set pass equal to simple. So if we were to do something like that, oops. Why didn't that? Why didn't that run? We're using safe update mode. Okay. Okay, so this would allow us the functionality that we want where, given volunteer ID and a password, they could log in. In this case, everyone's got the same login. But we have a real problem here in our database. And the problem is that you can actually see everybody's password. And although we don't typically intentionally expose our database so that other people can see it, but things do get hacked. And if anyone were to get access to this, if we stored the passwords this way, we would be storing them non-encrypted, which means if someone was able to gain access to our password, or sorry, to our database, they would get their password for our volunteer database. But a lot of people use the same password. So then they could start using that password to see if they can get access to other things, such as their banking records or their credit cards, or I don't know, their Apple Music accounts, who knows what. So this would be considered a very bad practice to store a non-encrypted password. So what we really should do is we should store this in an encrypted way. And to do that, we're going to go into Java and create a custom class for creating passwords. So I'm going to go into my models section here, and I'm going to say new Java class. And I'm going to just call it password. Creator. Now, the Java libraries have numerous different ways of creating passwords and encrypting things. several different packages or classes. I don't know if it's in the tens or the hundreds, probably in the tens, probably less than 100, but there are a lot. And the one that we're going to work on today is called SHA. And SHA has several different sizes of it. The one we're going to use is called SHA 512. So that's one of the larger ones. Oops, did I call it? Oh, got a typo here. So I'm going to right click and refactor. Name. And what we'll do is we'll create a method here and we'll make it static. So I don't need an instance of my class. I can just and our method is going to have two things passed into it. Oops. We'll return a string. We're going to need to pass in password encrypt. And the other thing we need to pass in is something called a salt or a seed. Now the idea with this is we're going to use the SHA 512 set of libraries for encrypting whatever our password is. But if someone were to gain access to our database and they knew that we used SHA 512, there are, they could create a machine that would basically be able to go through all of the passwords and slowly decrypt them because they would know that this algorithm is all that they need. By adding in a salt or a seed, what we're doing is we're putting in another random thing into this algorithm. So what I like to do is for each password, we pass in a different salt. And what that means is, if someone were to gain access to our database and try to decrypt the passwords, they would have to run through everything for every password with a different salt for every single person. So it would take an exorbitantly long period of time, even with computers. I mean, any of these things can be decrypted eventually, but it will definitely slow people down. So what we're going to do here is we're going to create a generated password. Usually set to null. And we're going to use a tool called the message digest. It's a class. And here is where we pass in that we're going to use SHA 512. Okay, and then the salt or seed that we're going to pass in, we have to add this to our message digest. So we're going to say message digest dot update, and we'll add in the salt. So now we have our utility, and we use an array of bytes. And we pass in our password to encrypt. Okay, so this, did I spell it different? There we go. So this will use this utility and this SHA 512 plus our salt, and it's going to convert our password into a string of bytes. And what we're going to do is convert that string of bytes back into characters. Right? So for each byte that's returned in our array of bytes, we're going to convert them back. So we're going to say string builder append. What's it complaining about? So again, we're going to loop over top of this array of bytes, and we're going to convert those bytes into characters that could be stored in our database. And at the end here, what we're going to do is we will return our generated password. Not a method, it's just a variable. Okay, so now with our password generator, we can call the method get SSH12. We pass in password to encrypt and a salt, and we're good to go. It'll return a password. Now, the other thing we need to create is the salt. And we want this to be as random as possible, this salt. We don't want it to be predictable in any way. So what we're going to do is let's create another method that will create a salt for us. So this method, we're going to use a class called secure random. Now again, with passwords, the whole idea is to create things that it cannot be predictable. And secure random is much stronger at randomizing things than the math.random class or even the random class. So what we're going to do here, let me just import some files. We're going to say secure random. We can get an instance of it, but what we're going to do, there's different algorithms. You can pass in an algorithm, such as like an SXA type algorithm. But I'm going to say get instance strong, and then it'll pick a strong encryption, or sorry, not an encryption type, but a strong randomizer. And then we'll create an array of bytes that I'm going to call the salt. And we'll return that. And that should give us a random number each time, random set of bytes. So let's just give this a little test drive here. We'll call it a PW tester. Simple class. We'll create a little loop here, make sure our salt's random. We'll do password generator dot salt. Throw an exception here. We'll convert that salt to a string. Still complaining. All right. Oh, jeepers. There we go. Okay, so let's try running this file. So you can see each of our salts creates a random set of bytes. Okay. So looks like our salts are definitely unique. And I'll say string. So if I were to create, do some random passwords here. I can say password generator, get the password, and for the salt, what we'll do is we'll say password generator, get salt. All in one line. So in theory, what this should give us is the word simple translated into 10 different passwords, each with a different salt. So let's try running this. So there we go. So if we look, the same password, the word simple, with one salt is translated into that great big long string of characters. And then with a different salt, it's different. And you'll see each of these is always going to be different. And then similarly, if I know the password and I know the salt, I can never convert this back to the password, but given the password and the salt, I should be able to recreate the exact same combination. So if I looked at this and I said, if I know the password and I know the salt, I should be able to validate a password. So If I ran the same thing twice, right? So given the same password and the same salt, so here we change the salt, we get different outcomes each time. Now, if I use the same salt, I should get the same password each time. And in fact, we do. Okay, so if we know the password and we know the salt, we can always create this encrypted password. And then really what we're going to do is this is what we'll store in our database. And then when we go to log in, we'll encrypt the password and see if it matches what's in the database. And that's what we're going to do in the next video. So look forward to having you come back. Take care.